Hydrogen fuel cells, a type of proton exchange membrane fuel cell, operate by utilizing a proton exchange membrane to convert the chemical energy of hydrogen at the anode and oxygen at the cathode into electrical energy through an electrochemical reaction. Carbon paper is a common material for the spark layer of the membrane electrode of hydrogen fuel cells. It bears the responsibility of supporting the catalyst layer and transferring oxygen and reaction products. The materials need to 1. Have a suitable pore distribution to facilitate the conduction of the reaction gas, 2. Have good strength to support the catalytic layer, 3. Have a suitable thickness to achieve strong air permeability, strong support and low cost. Gas permeability. Under appropriate porosity and pore distribution, carbon paper should have good gas permeability. Due to differences in technology and process, there is no unified index requirements for air permeability of carbon paper. Therefore, most companies refer to GB/T 20042.7 to 2014 to conduct self-assessment of the gas permeability of carbon paper materials. In terms of testing, the sample of carbon paper is clamped in the air permeability tester, and gas flows in to maintain a certain pressure difference on both sides of the sample. The software automatically measures the gas volumetric flow rate and obtains the gas permeability of the sample by calculation. As a rule of thumb, the air permeability of carbon paper is generally high, so an instrument with a suitable range should be selected. Labthink gas permeability tester has a gas volume flow rate measurement range of 0 to 30 liters per minute, and customized instruments with a wider measurement range are available. The pressure difference setting range of the tester is 0 to 1000 pascals, so the users can flexibly adjust the pressure difference to obtain more accurate gas permeability values. The instrument has built-in high-precision electronic gas flow sensor and gas pressure sensor, which are convenient for accurate control and monitoring of gas flow and pressure changes during the test. Tensile strength. Carbon paper must have appropriate mechanical strength to enable it to support the catalyst layer. Therefore, in the research on improving the mechanical properties of new carbon paper, as well as in enhancing key indicators such as conductivity, porosity, and hydrophobicity, it is necessary to always pay attention to changes in performance values, such as tensile strength. According to the provisions of GB/T 20042.7 to 2014 Proton Exchange Membrane Fuel Cells, Part 7, cut the carbon paper into strips and clamp them on the auto tensile tester. The center lines of the upper and lower clamps should be parallel to the direction of force of the sample. Stretch at a speed within the range of 10 to 100 mm per minute. The tester will automatically calculate the tensile strength value after the sample breaks. If necessary, the sample is sampled and tested in the longitudinal and transverse directions to understand the difference in tensile strength of the carbon paper in different directions. Thickness uniformity. The thinner the gas diffusion layer made of carbon paper, the better it is at conducting gas and reducing resistance. However, considering the strength requirements for the catalyst layer support, different thicknesses should be designed according to different application environments, and ensure that the carbon paper has good thickness uniformity. According to GB/T 20042.3 to 2022, the thickness uniformity test should use representative samples without wrinkles, defects, or damage to prepare samples with an effective area of at least 100 square centimeters. In a standard laboratory environment, 23 degrees Celsius, 50% RH, use a contact thickness gauge to test the thickness values of multiple evenly distributed points, ensuring that each 25 square centimeters sample has no less than 9 test points. Test 3 samples continuously, and automatically measure the average thickness value of the carbon paper, thereby calculating the thickness standard deviation, thickness dispersion coefficient and other values. During the test, the measuring head of the thickness gauge must maintain a certain pressure in contact with the sample, and 5 newtons per square centimeter is generally recommended. Currently, Labthink has joined hands with many enterprises, institutions and scientific research institutions in the new energy industry, actively leveraging her experience in instrument R&D, manufacturing and testing, focusing on the fuel cell industry, conducting in-depth cooperation, and jointly promoting the rapid innovation and development of the new energy industry.
Labthink since 1989.